You know that it's harder to do things with your non-dominant hand. It's harder to write, it's harder to cook, and when I try to brush my teeth with my left hand, I look less coordinated than a baby panda. But there are also times when the rules don't apply, like typing, tying your shoes, or playing an instrument. This is because of something called neuroplasticity, or the process in which your brain is constantly adapting. People used to think that your brain fully developed in childhood and couldn't significantly change afterward, kind of like the expression, an old dog can't learn new tricks.
Is that true, buddy? Touch, touch. Oh, you're a good boy.
Bo is right. Although neuroplasticity peaks in childhood, it is present throughout your life, which was only recently discovered as scientists examine the recovery of a brain after a stroke. Although affected parts of the brain couldn't regenerate, the rest of it was able to rewire and take on different functions. This proved that even after childhood, the brain could still change and grow. And neuroplasticity isn't just used to recover from trauma. You actually use it every day when you learn new things. Every time you think about something, you're using a neural pathway, firing up an electrical signal that travels through interconnected neuronal chains. When you activate their electrical signal using a chemical reaction, that's called action potential, and it's how you process information. Think about taking a language class in school. Every time you go to the class, you learn new words and repeat old words until they become second nature to you, forming a mental connection.
¿Te gustan los tacos?
Sí, me gustan mucho los tacos. However, this isn't a one-time occurrence. Neural pathways can get stronger or weaker over time when you practice or forget things. Like when you stop going to school, you stop practicing your language, and the words slowly fade from your vocabulary.
¿Te gustan los tacos?
Sí, mi nombre es taco. So, what happens? The more action potentials occur within a synapse, the stronger its electrical signal gets. That's called potentiation. The inverse of this process is called depression. I told you, Mom, I'm fine. Not that kind of depression. It just means the less you use a neural pathway, the weaker its electrical signal becomes. There are two ways to strengthen or weaken a neuronal pathway: synaptic or structural. For example, you could go through synaptic potentiation, where you use more neurotransmitters in order to create a stronger electrical signal. Structural potentiation works in a similar way, except on a larger scale. In this case, you're increasing the number of neurons in a neuron chain, causing there to be more connections between the axon terminals and the dendritic branches. To summarize, every day your brain changes based on what you do and how you think. Long-term habits can affect the structure of your brain in a process called neuroplasticity. So I dare you to skip the Italian brain rot today
Scimpanzini bananini.
and try something new.